We're going to finish notes for lesson 9.1. Not only are we graphing quadratics, now we're going to compare quadratics. So you're going to be graphing two equations on one coordinate plane, and then you're going to tell if it's a stretch or shrink, and if it's a reflection or translation. These are your directions. Graph the function. Compare the graph with the graph of y equals x squared. So I'm graphing y equals x squared and the new equation that they give us. The good news is you will always be graphing this. This equation will never change. So once you find 5 ordered pairs for this equation, you don't have to do it over and over and over again. So let's start by finding y equals x squared. In fact, I might just do it on a post-it here. And I can just move the post-it so I can see it every time. I'm going to make a t-table for y equals x squared. And I'm going to do my 5 ordered pairs. So I'm going to pick 5 x values. So plugging in -2 first. -2 times -2 is 4. And then -1 times -1 is 1. 0 times 0, 1 times 1, and 2 times 2. So I'm going to be using those 5 ordered pairs for y equals x squared every time. Let's find some ordered pairs for y equals 3x squared. Always using -2, -1, 0, 1, and 2. Plugging in -2 first. -2 times -2 is 4. So I get 12. -1 times -1 is 1. Now 0. 0 times 0 is 0. 1 times 1 is 1. I should be seeing these repeat here. 2 times 2 is 4, and 3 times 4 is 12. I'm going to graph both y equals x squared and y equals 3x squared on the same coordinate plane. My y values go as high as 12. Y equals x squared will always be the original, so I'm going to graph that first. I think I am going to go up by 2's. And my x values are going to go up by 1's. So -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. This is the original. Y equals x squared will always be the original. And then I'm going to graph my new equation. This y equals 3x squared. -2, 12. -1, 3. 0, 0. 1, 3. And 2, 12. Okay, 2 things could happen here. First, I'm going to decide if there's a stretch or a shrink. Stretch means that the new equation is larger. Shrink means that the new equation is smaller. There's 2 ways to tell. I said that this was the original and this is the new. I see that it's larger, so I call that a stretch. Or you can compare the y values. This is the original, this is the new. I go from 4 to 12, gets larger, so it's a stretch. After you decide if it's a stretch or a shrink, you're going to decide if it translates or rotates at all, or reflects, I should say. Translation means that the origin moves from one place to another. Here the origin is in the same spot. Reflection means mirror image. One parabola is on the top, one parabola is on the bottom, and it's neither. So this is just a stretch. Push pause and try this problem here. We're going to be comparing this equation to the original, this y equals x squared. So I'm not going to redo the x squared. I'm just going to do the t-table for the new equation. And because we're dividing by 3, a third of a number is the same as dividing by 3, I'm going to pick numbers that are multiples of 3 instead of these 5. So for example, I'm going to choose 6, 3, 0, -3, and 6. So 6 times 6 is 36. A third of 36 is the same as dividing by 3, which is 12. Oops. Okay, now I'm going to plug in 3. 3 times 3 is 9. 9 divided by 3 is 3. 0 times 0 is 0. A third times 0, or 0 divided by 3. And last one. Oops, this should be a negative. If you chose to use 2, 1, 0, -1, and -2, you would have fractions over here, and there's nothing wrong with that. And then because my y values go to 12, I think I'm going to go up by 2's on the y-axis. If you chose to use 2, 1, 0, -1, and -2, you probably wouldn't have to go up by 2's. Okay, start with the original. The original is -2, +4, -1, 1. Whoops, that's not 1. 0, 0, 1, 1, and 2, 4. Now the new equation is 6, 12, 3, 3, 0, 0, -3, 3, and -6, 12. This time I see that the equation is under the original. The new equation is under the original. That means it's smaller, so it's a shrink. It's kind of hard to compare our y values here because I chose different y values. But if I were to plug in 1 here, 1 here, I'd get 1 times 1 is 1. 1 divided by 3 is 1/3. So to compare this ordered pair right here, 1 and then 1 and 1/3, it gets smaller, so it's a shrink. Now I'm deciding if there's any translation or reflection. The origin doesn't move, so it's not a translate, and the new parabola is not underneath the old parabola, or it's not a mirror image, so it's not a reflection. Now I want you to kind of see the patterns here. You can kind of guess what's happening before you even graph these. If this is always going to be original and you're taking the originals and you're multiplying by 3, your graph should be larger. It should always be a stretch. If you're taking this original and you're dividing, so if it's a fraction, it's going to be smaller, so it will always be a shrink. Okay. Push pause and graph this one without my help. Remember that you're comparing it to this original, y equals x squared. I'm going to make my t-table. And I'm going to use -2, -1, 0, 1, and 2. And plug those in. -2 times -2 is 4. -2 times 4 is -8. negative 2 times 1. Zero times 0 is 0. 0 times negative 2 is 0. Negative 2 times 1 squared. One more. So I have positive y values and I have negative y values. Because I'm not going to go up by 2's this time, I guess I'm not going to label it. Let's graph our original equation first. Negative 2, positive 4. Negative 1, 1, 0, 0. This is symmetrical. Now the new equation, negative 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2. 0, 0. 1, negative 2. And 2, negative 8. Okay, so now to the compare part. Let's decide if it's a stretch or a shrink. This is the original, and this is the new. It's kind of hard because one's on top of the x-axis and the other parabola is underneath the x-axis. So you could look at your ordered pairs and compare. Now, I'm not thinking of negatives. I'm taking the absolute value here. So if I'm comparing the y values for negative 2, one's an 8 and one's a 4. Again, I'm taking the absolute value. I'm ignoring the negative out front. If this is the original 4 and this is the new 8, it's larger, so that means that our new graph stretched. So for stretch and shrink, you're ignoring the negative out front. This is a whole number, so I know that it's growing. If it were a fraction, like the problem below it, or the problem before this, it would be a shrink. Now that I know stretch or shrink, I'm going to compare translation or reflection. Because it's a mirror image, one parabola is on top and one parabola is on bottom. This is also a reflection. All right, push pause and graph this one, then compare. Okay, y equals negative 2 squared plus 5. Oops. All right, graphing both of these on the same coordinate plane. I'm going to go up by ones. Graphing the original first. Negative 2, 4. Negative 1, 1, 0, 0, and it's symmetrical. Okay, now the new equation. Negative 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 6. 3, 4, 5, 6. 0, 5. 1, 6, and 2, 9. Let's compare stretch or shrink. In all of the other previous problems, I've told you to compare the y values. That will not work here because there's no a term, so be very careful. This is a different type of problem. This is not a stretch or shrink, because if I were to take this new parabola and put it over the old parabola, they would sit right on top of each other. It doesn't get larger or smaller, so not a stretch or shrink. But I do see that the graph moves from one place to another, so this is a translation. So lots of patterns going on here. Some people are just going to be able to look at the equation and kind of know what's going on. Otherwise, I kind of have a flow chart for you here. I think it is important that you write this down. When you're comparing to this original equation, a couple different things can happen. In your equation, if the a term is a whole number, so 1, 2, 3, 4, 5, so on and so forth, and it's positive, it's just a stretch. If this a term is a negative, it's a stretch and a reflection. If this a term is a fraction and it's a positive fraction, it's just a shrink. If this a term is a fraction and it's a negative, it's a reflection and shrink. Then here's a different type of equation. This equation, just like this one up here, didn't have an a term, but it has a c term. In that case, it's just a translation. So those are the 5 different possibilities. 1, 2, 3, 4, 5. On today's lesson, they're going to have you graph the old equation, graph a new equation, and compare, just like we did in these notes.